We want to simplify the given expression. So looking inside the parentheses, notice how here we have x minus y, and here we have y minus x. And therefore, these two variable expressions are opposites. To show this, let's rewrite y minus x as negative x plus y. So the given expression is equivalent to 5 times the quantity x minus y divided by, again, y minus x is equivalent to negative x plus y. I'm going to go ahead and put this in parentheses, and all this is squared. And now it's probably easier to see that these two variable expressions are opposites. So what we can do now is factor out negative 1 from negative x plus y. So if we did that, inside the brackets we'd have 5 times the quantity x minus y. Now if we factor out negative 1, that's just going to change the sign of these two terms. So we'd have positive x and then minus y. Notice how if we distribute, we still have negative x plus y. But in this form, notice how we have the quantity x minus y divided by the quantity x minus y, which simplifies to 1. So now inside the brackets, we just have 5 divided by negative 1, which is negative 5. And negative 5 squared is equal to negative 5 times negative 5, which equals 25. So this would be one way to simplify the given expression, and probably the fastest way. But let's also show this another way. Another way to simplify this expression would be to not simplify inside the brackets, but to include the exponents. What I mean by that is we can write 5 as 5 to the first, and the quantity x minus y is the same as the quantity x minus y to the first. And then in the denominator, we can rewrite y minus x as the quantity y minus x to the first. In this form, we have powers raised to powers, so looking at the exponent rules below, whenever we have powers to powers, we multiply the exponents. So the given expression is equivalent to, in the numerator we'd have 5 raised to the power of 1 times 2, which would give us 5 squared, times the quantity x minus y raised to the power of 1 times 2, which would be the quantity x minus y squared. And then the denominator, we would have the quantity y minus x raised to the power of 1 times 2, or the quantity y minus x squared. And now we'll go ahead and multiply this out. Of course, 5 squared is equal to 25. To square the quantity x minus y, we want to write out both factors of x minus y, and the same thing for the denominator. To square the quantity y minus x, we want to write out two factors of y minus x. And now to multiply two binomials, we'll always have four products. To find this product here, we distribute x first, then distribute negative y. In the denominator, we would distribute y first, then distribute negative x. So if we do this, we'd have 25 times x is x squared. Next we have x times negative y, that's negative xy. And notice how the next product would be negative y times x, which is also negative xy. So we have minus 2xy. And then negative y times negative y would be plus y squared. And now multiplying the denominator out, y times y is equal to y squared. Y times x is negative xy. And then we have negative x times y, which is also negative xy. So we have minus 2xy. And then negative x times negative x is plus x squared. Notice how when we square these binomials, the two products are equivalent. Here x squared is the first term, here it's a third term, here y squared is a third term, and here y squared is the first term. So we can rewrite this as 25 times the quantity x squared minus 2xy plus y squared. And then for the denominator, just to make it easier to see, let's write the x squared first. And then we have minus 2xy. And let's write the plus y squared last. Notice how these two trinomials are the same, and therefore this quotient is equal to 1, and therefore once again the given expression simplifies to 25. So whichever method we use, the given expression does simplify to 25, and we should make a note here, this is true as long as we don't have division by 0, which would occur when x equals y. So for this expression, we assume x doesn't equal y. I hope you found this helpful.